Hi everybody and welcome back. We are now going to talk about solving logarithmic equations. So these are not terribly difficult once you know the properties that we saw a couple videos back. So kind of the idea is each side of the equation, if it has log in it, you want to isolate that logarithm. So in this case we have log x minus log 8 equals 10. So what we're going to do is the subtraction property, log of x minus log y equals log of x over y to simplify the other side of the equation. So we'll have log of x over 8 equals to 1. And now what we want to do is a property we saw in the exponential section is that we want to make each side of the equation the power of some base. And the base we want to match is the one for the logarithm here. Since this is a common log, we're going to use 10. This is going to be 10 raised to the log x over 8 equals 10 to the first power. And because these are inverse functions, we're going to use one of our solving properties to isolate and get us x over 8 equals 10. And multiply both sides by 8, we get x equals 80. And so that's our first example. So notice that the idea was that we combine the logarithms, make, since this, we also have this property that m equals n is equivalent to a to the m, or b to the m equals b to the n, and I use that property with b equal to 10 to write this line. Then that allows me to do the cancellation here and solve for x. So let's look at another example that's similar, just a little bit more complicated, and the same basic procedure applies here. But this time we have a product of two things, so we're going to write this as log of x minus 9 times 100x. This is going to be equal to 3. So this is all in one big parentheses. So let's simplify that. So this will be log of 100x squared minus 900x is equal to 3. And now we do the same trick. This is common log, so this will be 10 to the log of 100x squared minus 900x equals 10 cubed, and the log and the 10 cancel, and we get 100x squared minus 900x equals 1,000. We can divide everything by 100 and get x squared minus 9 equals 10, or 9x equals 10, and so we get that x squared minus 9x minus 10 equals to 0. And we need two things that add together or multiply together to be 10 to add to be 9. And so the factors of negative 10 to add to be negative 9 are negative 10 and positive 1. So we'll have negative 10 minus or times x plus 1 equals to 0. So we'll get x equals 10 or x equals negative 1. And notice that here, like before, with all logarithmic equations, we have to check our answer. And notice that when we have negative x, we get a negative 1 minus 9 for x equals 1. And notice that that is not possible. So notice that this answer is not true, and we have that x equals 10. So for these type of problems, it is important to check your answers and make sure they make sense up here. And notice that we did get one value that was outside the domain. So just x equals 10 in this case. So finally, we have this expression here. So now we have a logarithm on each side of the equation. So the easiest way to do it is just to simplify the logs on each side and then use our property that we can choose a base and make these both sides of the equation the exponent of that base. And that's kind of the easiest way to tack on it. So the left-hand side will become log of 6x plus 5 over 3. And the right-hand side will be log of 2 over x. Now, since this is base 10 still, we can make both sides of the equation, and that needs a log there, the exponents of exponential function with base 10, so we can cancel off the logs. We get that 6x plus 5 over 3 equals 2 over x. And so this means that 6x squared plus 5x is equal to 6 by cross multiplying. And so we'll have 6x squared plus 5x is equal to 6, or minus 6 is equal to 0. And this one we have no choice but to use the quadratic equation. Well, let's see. We need factors of negative 36 that add to 5. So let's see if there are 1 and 36. I don't see it. So let's see. 2 and 18 don't work. 3 and 12 don't add up to 5 in any way. 4 and 9 do add up to 5. So here we go. I didn't think we were going to find 2, but we did. So we need a positive 5. So this is going to be positive 5 at minus 4. So I'm going to rewrite this as 6x squared minus 4x plus 9x minus 6 equal to 0. And in the first two terms, we can factor out a 2x, and this is a 3x minus 2. We can factor out a 3, so we'll have a 3x minus 2 equal to 0. And notice we have a 3x minus 2 in common, so we can factor that out. And at least mine a 2x plus 3 equal to 0. So this gives me that 3x minus 2 equals 0, or 2x plus 3 equals 0. And so this means that x equals 2/3, or x equals negative 3/2. And then we need to make sure these answers make sense. And putting a positive number in here doesn't matter, but if we take 6 and multiply it by negative 3/2 and add 5, we just need to check to make sure that's not 0. Oh, actually, that's not even the issue here. We can actually just say that, well, log of x can't take negative values, and when we got a negative, one of our solutions is negative, so we have to throw it out, and so we just get negative 2, or we get positive 2/3.